All right, well, welcome to the Phoenix DevOps meetup. If you haven't heard me say 8 times already, there's drinks and snacks outside. Those are for us, so get some before they're all stolen by someone else. And today, my name is Kuenzli, and today we're going to be talking about delivering secrets to applications, and what I really mean are server-side applications, and doing that securely. And this is a bit tricky. So I'm going to provide a bit of a survey of the space, and hopefully it'll make sense. If something doesn't make sense, go ahead and just kind of shout out. I will try to repeat the question and then answer you. And this is being recorded. So if you want, assuming that all works out, we'll post the links to that. And then you're free to follow up with me whenever you want to dig into details, because there's a whole bunch of stuff that I'm not going to talk about. If you think of this in terms of an iceberg, this is definitely the stuff not just above the water, but like, the top 15% of the iceberg. So, all right, with that, I'd like to go in with delivering secrets securely. My name is Steven. I've been building systems for about 20 years. And been very active in the DevOps space and automation, doing this with infrastructure as code and so forth. And I write about a lot of this stuff, and I'm going to reference some stuff later. I write about topics like this on a blog called No Drama DevOps. And what I'm really trying to help you do is like build systems and deliver applications with less drama. So with that, let's start with, how do you lose a secret? Here's some ways, some of the top ways. You can store them unencrypted in source control. You can store that file in some way that's widely accessible. This is actually the core of the Equifax breach. There were one server, so the Struts side of the world got a lot of attention here, but the pivot was the really interesting part of that problem, in that a server in the DMZ got breached, and that server happened to have access to literally a list of usernames and passwords that was shared across the whole environment, and something like 70 odd systems. And so the attackers were able to go and connect to those things because there were other failures. But anyway, a key part of that story is the fact that there's a file with secrets that was overly scoped and easily accessible to an attacker. You can lose a secret by storing secrets in your CI/CD systems like Secret Store, and then not putting any access controls around those secrets. And many of the CI/CD systems consider, or either they don't have a way to put access controls around secrets or environment variables, or however they want you to handle confidential data. And then other systems, like they don't come included, or they're hard to configure and people don't have them. And so oh, well, you can just reference the production AWS deployment key, if you want to. Or by accident. Another way is to build a secret into an application artifact that gets copied around and packaged and deployed into systems that aren't really designed to keep tight control of a secret. Maybe they get stored in an environment variable and leaked into some other process, or they're available to another process in that same shell or execution context. Might get printed on a command line when starting an application, or just in a log, as Facebook did recently. Oh, I guess that's 7. Anyway, there's lots of ways to lose control of your secrets. So I'm going to talk about how you secure at least the first part of the delivery process. Like once it gets in the application, not much, we're not going to talk about that stuff today. So I want to start with what I call the first secret problem. And this is a general problem in the security space and delivery space, which is like you have to bootstrap trust of your application process. And if you can't publish application secrets inside your application artifacts, whether that's a compiled binary or a config file, or startup configs that are in a jar or a zip file or whatever, because you're going to put that into an artifact repository, and that artifact repository doesn't have good access controls and so forth. Like, well, how do you get your passwords, your API keys, and certificates into your application runtime? Like, well, you need to leverage a thing called platform identity, which is something that your compute platform can provide you. So let's say, and we're going to step through this in more detail later. But basically, the way this works is, say you're running on, say, AWS EC2. Well, you have a computing service and you have an identity and access management service, and both of those are managed and operated by AWS. And when you start a virtual machine, you can give that virtual machine an instance profile or instance role, and this is called a service account in Kubernetes and a service account in GCP, and I think it's a service principal in Azure. But you give that virtual machine, you say this is the identity, and then when the application starts up, it can use the credentials for that execution role to obtain short-term, ephemeral, transient credentials that then it can present to something like a secret store or a database system or whatever. Like, you don't need to, and you shouldn't give long-lived static API access keys to applications running on a compute service that in order to access other services on that same platform. So like, take the AWS case again. If you're running on EC2 or let's say Lambda, you can use these short-term credentials provided by the platform to go and access RDS. And if you need to grab an API key to talk to Datadog or some other third party, well, that's the kind of secret that you would put in a secret store, and then use the instance role, the instance execution role, to authenticate to that secret store and pull out. And then your secret store can decide based on that role and that identity whether or not your request to retrieve that Datadog API key should be permitted or not, whether it's authorized. So this is how you bootstrap generally. So this is important. Are there questions on this concept? Yes, sir. Yeah. So the question is, what if I'm not using a cloud provider, and how do I deal with this on-prem? So if you have a configuration management system like Chef or Puppet or whatever, when that machine is first initialized, it needs to talk back to the mothership and register itself. And classically, Puppet would require the operators to explicitly allow the retrieval of manifests and so forth to complete the bootstrapping process. So in the cloud world, this process is all happening just automatically. Like, and the control plane in this initial bootstrapping is all automated and needs to be secure, right? In particular, when like in a physical environment, if your data center operations folks, like you really need to make sure that only trusted people are spinning up hosts. And so that they come up with a proper identity, join as a proper role, or be ready to like, well, usually I would probably do like a minimal provisioning initially, and then let those roles be provided by someone else. But anyway, there's a similar activity. Is there any other? Was there another question? Yeah.
In AWS, is the secret store their KMS service or their?
So in AWS, the kind of native secret stores, and we're going to talk about this, are first, I'll say parameter store, which is probably one of the most underused and underutilized systems in AWS. There's also a thing called Secrets Manager now, which I have a feeling is built on top of parameter store with some workflow. And then you can implement your own system using object stores plus policy, bucket policy language. And that's true of all of the, anything with an object store really. We're going to talk about that. So moving on, like how do we actually transmit these secrets? So first off, I want to define secret, and I'll define it as a specialized configuration that authenticates an identity or protects some data. Secret may take the form of a password, an API key, a private encryption key, a client certificate, those things. And it's probably going to be best to look on the right side here. The left projector is a little out of focus. But if you think about secret delivery within the context of an existing application process, we're like in kind of the development phase. We might be generating some secrets, defining them, and putting them in a source vault. And then in continuous integration, we build application artifacts. And then we need to, and we might very well, and it's very common to use secrets within even just building an artifact. If you think about building a virtual machine image, you're often publishing that virtual machine image to, like, number one, you need to like retrieve a source image, and then you're going to publish that image somewhere for retrieval later. So this is not just a delivery problem. It also happens in build phase. But moving on to build or delivery, well, once we distribute an artifact like in a virtual machine image or a Docker image or the application, like a zip file from Lambda, we want to do that. We want to deliver that artifact into a runtime domain. And what I mean by that is we need to put that virtual machine image and publish that virtual machine image or Docker image or zip file into the AWS account or the GCP account that thing is actually going to run it. And it's not necessarily the same place that we build it. And so, because we're trying to make it available for runtime. And one of my principles here is that, so there are multiple ways to do this, of course. I am suggesting a way here that fits with my own model of high availability, security, fault tolerance, etc. So one of the things I want is I want the runtime environment to be free of dependencies to the left. I want everything in the runtime environment to be self-sufficient, more or less, because it's a specific security management and fault domain. And we're going to have many environments, and like the rules and what happens in dev are kind of different from what happens in production, right? So we need to. So I said previously that a secret is a specialized kind of configuration, and we've distributed our configuration along with like application binaries and so forth in this level. So what I'm going to suggest here is that you also distribute your secrets at this point in time, just after you distribute your application artifacts and configuration. And then you can move on to doing things like updating your deployment descriptor to say, yes, I want you to use the new version of the artifacts to run, so the function is now implemented with this version of the artifacts, or update your auto scaling group to use the new AMI or whatever after everything is already in place. And like all the static artifacts are in the runtime environment that you're going to need to run. And so that's just this is like a high level process. Now drilling in, let's define another thing, a vault. What I mean by vault is a vault is a data store that's specifically designed and implemented to store secrets safely and then broker access to those secrets via an API, hopefully. A lot of the classic vaults and hardware security modules seem to be geared towards a user, like a person, accessing, and like this, there's a whole class of products called privilege access management products. A lot of these products don't seem to fully account for application delivery, automation, let alone doing that in a highly ephemeral environment like most cloud deployments. But anyway, this is what I mean by a vault. And your secrets go inside the vault. So maybe a little small. So within that distribute secrets step, there's a process of taking a secret from a source vault. And that could be a file, it could be an HSM, a hardware security module, it could be something like HashiCorp Vault, it could be some cloud object store, something, whatever you consider your system of record to be. And then I am going to suggest, I'm going to explain why in just a bit. I'm going to suggest that you basically make a copy of those secrets into whatever your runtime vault is. So whether that's SSM or Azure Key Vault or some other vault in the target runtime environment. And that's what applications are going to read. That's what I'm going to suggest that applications should read their secrets from. And then this goes actually back to that security and management domain. Like, do you want to expose your secret vault, your system of record, to arbitrary things running in dev, right? Probably not. A lot of people do that, right? Because they only have the one hardware security module. This is kind of an example of a dependency problem. But as I mentioned, a vault that serves as a system of record for a secret, that's what I'm calling a source vault here. And within continuous integration and delivery, you should use a narrowly scoped identity to access that source vault. This will help, and this is just kind of a general application of principle of least privilege in some sense. But importantly, like if you have jobs and users and teams for one organization or one business unit or team within a large organization, you would really prefer that they'd not be able to read the secrets or let alone manipulate them for another team or organization, whether by accident or by intent. And then, as I mentioned, in this model, applications do not need access to a source vault because we're copying them into the runtime domain. And then the target vault is hosted alongside the application in the same management vault and security domain. And you also should use policies that make sure that only application A can read application A's secrets and not application B's, and vice versa, stuff like that. You solve the first secret problem by using that cloud platform or configuration management system provided identity to bootstrap your access into the secret vault. And of course, this system needs to be highly available. And I'm working with someone who's HSM, like they're trying to find some time to take a maintenance window because it's not, even though it has multiple systems, it's not actually highly available to perform an upgrade. And so they have to like schedule this very carefully, and like ideally it's going to be like 2 hours of downtime, which means they actually can't deploy. They can't deploy. Fortunately, they don't have a deploy dependency. They don't have actually a runtime dependency on this thing. But you can imagine if they did, like that would be a big problem. Like, so there's a lot of tools for distributing secrets out there. None of them seem to do what I just described, and especially in terms of being able to map multiple secrets from multiple sources into like a runtime vault. But the leading solution really is custom scripts, and I put a little link to a nice discussion on Twitter about like people getting configuration and secrets into Docker containers, and it's 90% of the answers are something effectively custom or different. A tool that is going to pop up a lot, and I think is a great place to start, is Mozilla's SOPs tool, which allows you to, which helps you encrypt configuration and secret data inside your application source repository. And by the way, these slides, I'm going to make them available at the end, so you don't need to necessarily write any of this down. So SOPs, it will encrypt in using things like PGP, Azure, AWS, and GCP key management and encryption services. And you can actually basically generate encryptions for all of those if you want. And so what you can then do is actually distribute the encrypted version. And then when the application starts up, it uses the cloud encryption service to decrypt the file as it starts using that cloud identity, which is pretty neat. So in terms of getting started quickly, SOPs is probably one of the easiest ways to get started quickly, where it kind of starts to break down as or can break down or get complicated quick is how do I share common configurations and my key management overall and stuff like that. HashiCorp Vault provides a nice kind of end-to-end solution if you're willing to buy into the greater HashiCorp ecosystem. But one of the things that you want to be careful about when adopting and building out a workflow is to be careful about an anti-pattern or a pattern that I think is an anti-pattern, which is basically creating global secrets. And I think of these actually as global variables kind of in the sky, where you have multiple applications pointing to a single secret. And so let's work through an example. Let's say we're a Java shop. Well, what we might do is we might have 15 applications that all need some sort of access, or 15 microservices that need access to the same database. And so that database JDBC connection URL might contain a username and password. So it's secret, sensitive material. And so we say, okay, I know the solution. We'll put that in a secret in the parameter store. We'll encode that as a secure string. Well, now you kind of have a problem in terms of change lifecycle, because as I said earlier, a secret is like a configuration, and in that its change lifecycle changes similarly to code. It can change for reasons other than a code change, of course. We might change the literal name of the database of the database, but we have to incorporate this into a change deployment workflow. And so if we change the name of, or we change the, say we're using a new feature in the database connection string, well, and it requires a library upgrade. Well, we can't just update that single value of like a JDBC connection. Because now if another application, another one of these 15 applications that uses that secret has to start, then it might not know what to do with that value. And even older versions, say application B is the first one that we update. And like application B v2, let's say it knows what to do with this new value of this JDBC connection. Well, v1, maybe it doesn't. And so those might all break. And so it's a common pitfall to like, okay, now we've got our secrets out there, but not being kind of really cognizant of how the dependencies flow. And there's a small arrowhead. What this arrowhead is trying to indicate is that application A, B, and B2, application A, B1, and B2, they all depend on the same secret. And that's a problem because now the dependencies are all flowing in that way, and they can't, now their change life cycles are all mixed up with each other. So how do you deal with that? Well, there's a pattern that I'm commonly called version secrets, where you deploy a copy of an application's secrets alongside your application every time you deploy. Like basically take the deploy ID, job, deployment number, whatever, like put that into the name of the secret somewhere in the path. And what this means is now, say you deploy your application, everything's happy, you create, here's the dev, here's a config, v0. And then if you deploy a new feature in config, that becomes v1. If you update the config, like that becomes v2. And that's taken kind of from the way that Docker Swarm would do it, or the way you would apply this pattern in Docker Swarm. But the point is that like now my versions of my applications, they're kind of, they're independent of each other. And like, I don't need to like upgrade everything quickly or in some sense, right? Because they all carry their own dependencies.
In the previous slide, we had DB.
Yeah.
So should they have 3 independent secrets?
Yes, that's what I'm suggesting.
A separate password.
Yeah.
For each application, because then if one of them leaks, then you could invalidate one of them without invalidating the other. Because currently, if you were doing that, a secret leaks.
Perhaps. So the question.
And you have you have to deploy 3 applications.
Yeah. So the question was, am I recommending that application A and then B, V1 and V2 they each have their own secret? And the answer is a qualified yes. And I want to distinguish what I'm saying here. Say the value. I'm actually going to copy this. Oops. I'm saying they should each get a copy of the value. It may be the same value. Okay, so well equals 3, 4. Until here, let's say. Now this actually brings up another thing. So I'm not talking about rotation. And now rotation comes into this problem, right? Like, and should we when we update a key and we're trying to rotate out a key, and let's take Datadog. Say you've got your API key and it's shared by 15 applications. Well, you need at least 2 keys. You need your old one, your new one, so that you can, and enough time to switch between the two to rotate them out. And basically what I'm saying is that, like, if you start off with a Datadog key of 1, 2, 3, 4, and like you want to try out deploying that key with application B, well, you might deploy version 2 of that application, and like if it works, great, let's do more of that. But this way, you are really managing your blast radius and so forth a lot better, because one of the problems with like the global pattern is it becomes very difficult to change those secrets without creating like large blast radius is one issue. The other issue is unintentionally like breaking backwards compatibility, like in the JDBC connection example. So if you copy the value of the secret every time you deploy, then you can tear down, once you fully migrated to application BV2, you can tear down everything associated with application BV1, including the secret. And of course, the fact that you're making copies of secrets, like you have a garbage collection issue that you need to take care of in some way. So don't forget to do that. But it should be safer overall. And you can use things like secret usage reports to tell you which things that you ought to be able to collect. If a secret hasn't been used in 2 days in a runtime application, in a runtime environment, like maybe that's actually a pretty good sign that maybe you don't need it anymore. You can confirm elsewhere. So any other questions before I move on? Cool. All right, consuming secrets. Okay, fine, they're in the runtime environment. Woohoo! All right, yeah, all right, great. In retrospect, this might have been better earlier. So what is the actual sequence of events when you're reading secrets from a target vault inside your application? Well, let's consider this environment. We've got our artifact repository where our virtual machine or Docker images or whatever happens to be in the runtime environment. We've got our base level compute and IAM services and our secrets. And so boom, our orchestrator says, let's have an application. And maybe this is inside, we're deploying this, it doesn't really matter too much for this example. It could be a virtual machine, a container, a function. Let's start things up. We grab application and whatever your environment specific configuration artifacts are. And let's invoke exec a process. And along with this, our process and compute container is provided an IAM role, which identifies that compute element of compute, whether it's VM, container, or function. And then the compute service will typically provide some sort of metadata endpoint, which is a local thing, a local service in a special location. I forget the exact IP. It's a 169 IP, 169.254. something in EC2. But it's something that the application can request credentials for its role. And these are short-term credentials. A session token in AWS. And then it can say, hey, secret vault, let's go with parameter store. Give me my secrets, please. I'd like to read them from this part of, I'm going to read all these secrets from this part of parameter store, this path. Here's my instance role identity and credentials. And that's how you bootstrap those secrets into your application. And so, are there any questions on that? I mean, the real tricky bit is making sure that you can get these credentials, these initial credentials from your platform, compute platform. And then you can go off and try to read them from the right place. And then once you have your secrets, and the thing that did the reading, there's kind of 3 popular ways to get secrets inside to your actual application process. So I haven't really specified whether it was a script, like a startup script, or a cloud init, or an application itself, like retrieving those secrets initially. But let's get into a few ways, talk about a few ways to actually get secrets inside of a process. Environment variables, files, and an API. So in the first path, which is very popular, especially because of the 12-factor application world or style of programming, the application reads its secrets from environment variables. And so what had previously happened, let's say when we were retrieving the secrets, is that was done by a startup script. And it goes and uses like the AWS CLI, or it uses a tool like, let's take SOPs, the Mozilla tool. And it looked at the file that was encrypted, and it used IAM to get some credentials and run and decrypt that file using, or the data in that file, using GCP KMS. So now the startup script has the secrets, and what it will do in the environment variable case, it will export those secrets as environment variables. And this is a very common way. It's got some nice benefits. The lifetime of the secret is ephemeral. It's the life of the process in the startup script. And the application may already consume configuration or bits of configuration via environment variables. Like the application at minimum may do things like figure out or determine what environment it's running in, and like what configuration file to read even via like a node env environment variable. The issues with this pattern, I guess I had animations. Yeah, so we have a startup script. It retrieves some secrets and exports them as an environment variable. Then it starts an application process, and the application can go and do whatever it does. So the issues with this is that there are no access control mechanisms, not really, for an environment variable. So any process that is executed from within that same shell script, unless the environment variable has been carefully like unset and like unexported, you have all these bits floating around in environment variables, and there's no access control for them. So if the application process execs some other command, like image magic, let's say, which is a favorite attack vector, to do some image resizing. If you're not careful with how you exec image magic, it's going to inherit all of the same environmental stuff that you had, including perhaps some credentials for like that Datadog API or what have you. It probably isn't going to get something like a short-term token, but it's totally dependent on what you export it. There's another issue in that many applications will print their environment variables when you switch them into a debugging mode or they crash. Environment variables are often visible in various things using various tools, like depending on your, it might be visible in PS with certain flags. And if you're running as certain privileges. Anyway, so they can leak. Actually, before I move on, are there questions about how environment variables work or secrets? Okay. So files. An application can read its secrets from files. So, I got done, it's almost a truism now, like don't put your secrets like onto disk. And it's true. Your secrets, in this case, should go onto an in-memory file system to maintain the ephemeral nature of these secrets. And ideally, that in-memory file system should only be accessible to the application process that needs it. Container orchestrators and function platforms do this for you pretty much automatically at this point. One thing that you do need to be careful of is like you can use file system permissions to limit read access. So let's go through this example. So you've got your startup script or orchestrator. It makes a in-memory file system, and then it says like, oh, it goes off and retrieves the secrets and it writes them as files onto this in-memory file system. In the container world, the location of these files on the in-memory container file system is typically /run secrets, which is a de facto standard, if not a real standard at this point. And it will literally take something like a private key and put it into a file named after that secret. And then what your orchestrator or deployment scripter needs to do is typically tell the application, export an environment variable defining the location of that secret. So you don't put the secret into an environment variable, but you put the location of the secret on the file system in an environment variable. And the orchestrator should also have at this point used file system permissions to limit the file to be just read-only and owned by the process, by a particular UID, user ID, that the process is going to execute as. So not just, like don't make it world readable or whatever. And so then when the application process starts, now it can go off and it knows where this secret exists and where to read it from on its little in-memory file system, typically inside of a container. So kind of already gone through a number of the benefits. The main benefit of using files over environment variables are that you can use the file system access controls to limit access, and you can do things like delete them after startup. And I think that's pretty much it. Any questions on that pattern?
So you see the run secrets private then is the path name to the secrets. So that's how Docker does it. Does everyone else do it the same way? Or?
I don't know, because I doubt it, because I think it's not that common of a pattern outside of container folks. So
I guess does Kubernetes do it this way?
Yeah, Kubernetes. Yeah. So I'm using like, when I'm talking about container ecosystem, I'm including Kube, or Kubernetes. Sorry, that's my abbreviation. So yes, run/secrets is the de facto standard for locations of secrets, especially in the container world generally. So it'll work in Swarm, Kubernetes, and ECS, unfortunately, I don't think has a way to take something from parameter store and put it into a file directly. It uses environment variables right now. You'd have to do a little bit of glue, I think, to make that work with ECS. Is that correct?
As far as I know, yeah.
Will? Okay, yeah. Yeah. So one of the issues here is that you may require a little bit more application support, because you've got to like read some files, and this is like really easy in some languages like Golang, and a bit tedious in other languages. Now, the third option is having the application read its secrets directly from the secret vault. And the main benefits are that it eliminates, so well, actually when it starts up, the application process, boom, it reads from the secret vault. And mainly the big thing here is like a whole set of ways to leak that secret are eliminated just by virtue of implementation. And you also free yourself of a dependency with like your startup script needing to know the arrangement of secrets. Not sure how much of that, that's kind of like a theoretical, that might be like a theoretical benefit. But the main case I'm thinking of is like, and that I run into in a lot of places is like, well, that startup script is owned by team X and like, you know, the platform team or whatever, and you're a lowly application team and like you want to do something with secrets and but like it's not quite supported yet or something. That's more of a, I think, a benefit in a broken organization or an organization challenged by communication and collaboration. But anyway, those exist. So the main issue here is that the application or its framework that it's using actually needs to know how to read from secrets. And this may be from a secret store, and this may be either an advantage or disadvantage, depending on like whether or not like by policy, like you want to say like, well, this library is what we use to read secrets, and we have our, we trust it. We concentrate our effort in building this thing, and we, it's a key component in our whole secret delivery system and consumption tactics overall, because like we know how this works. On the other hand, like you may not be able to do that within your organization. Or it may be blocking, just like I was talking about, like, well, we need to do something slightly different in this team over here. And it's still responsible and compliant with policy, but it's not allowed. And we have to, get in line behind, put our request into some other team. So we may end up sacrificing some independence between teams. But there's plenty of things that do this. In particular, like Spring Cloud has a library that will authenticate with many stores, secret stores, and pull parameters down and secrets down. Let's see. So to summarize, keep secrets out of source control unless they're encrypted. Distribute secrets to a vault that is in the application runtime environment so that you have a cohesive set of like security, fault, and management domain policies. Leverage the application's platform identity to retrieve those secrets. That's actually probably the most important thing. And then I would suggest that, like, for most people, you prefer reading secrets from an access controlled file on an in-memory file system. It's pretty, anyway. In terms of improving your own process, I would probably recommend starting by looking at what Mozilla's SOPs tool does and seeing if that would work for you. And I think it works especially for highly independent teams or small teams. I think it's a little much when you start to try to scale the management and distribute like who can do what, like who can update a secret, and enabling application teams and like ops teams, if they're separate, to kind of collaborate. It's a little challenging, I think. But there's also several tools that have emerged to support that last mile secret delivery in Kubernetes using custom resource definitions. So I mentioned, I think one of them, Camus, but there's Helm Secrets, and Bitnami has a tool as well that I don't remember off the top of my head. But those are the key takeaways I'd like you to have from this. Yes, sir. Question.
You mentioned earlier, like getting to your database credentials out of your store and then being relatively short-lived credentials. So you mentioned short-lived credentials a few times.
Yeah.
I'm not sure what you meant in terms of like, if I have like just a server that, you know, we redo once a year or something. So it's a server that's running, like we're not spinning up servers and bringing down servers. Like, doesn't that same model where like, okay, like every time I need to hit a database for the next year, I need to hit my secret store and pull this into memory, and is it okay to keep it in memory for a year? Or like, are there those kind of long running boxes that are kind of different approach that makes sense there?
Well, so what I would say, I'm going to call this like a thing, passwords. So what I would put in the secret vault are what I'm going to call third-party passwords, private keys, API keys. So in general, within the scope of like your runtime environment. So where do you run your applications? AWS. Okay, so in this case, the runtime environment would be AWS. And you can use IAM generally to authenticate to other AWS services like say RDS, assuming your driver supports it. Now, not all drivers support it. Like the last time I looked at SQL Server RDS, the support for IAM credentials was like new. That was last summer. So you might have to use a traditional password, or maybe you need to use like a domain, Active Directory domain identity or something like that, right? So in that case, really what I'm saying is that like if you can authenticate yourself to a service using your cloud like AWS credential, and that's the short-term credential that comes right here, the one for your execution role that comes from a metadata endpoint. If you prefer using that where you can, because that's all rotated and automatically and handled by the AWS SDK. If you have a third-party password like that Datadog API key, that's going to need to come out of your secret store, and
that's not changing ever unless I go in and manually rotate that key myself.
Yeah, it'll change at some point, right? But and this is actually, so there was an interesting blog post that was circulating a few weeks ago around like how IAM is the real lock-in, and for AWS or any cloud provider really. And I think that to a large degree is true, that the magic provided by the hyperscale cloud like identity and access management services is just completely amazing to me, like in terms of being able to like authenticate and authorize access to like the whole ecosystem, or like a huge portion of the ecosystem of services within that environment, and to be able to do so transparently is wicked awesome. But you're not going to use cloud services, your single, a single cloud services for everything. That's just not going to happen.
One of the things I've been doing, so I've got a database, and one of the things we have social security numbers.
Yep.
So what I've been doing with that is I use KMS. So KMS, I connect to the KMS API.
Yep.
And it gives me back, so that's authenticated based on when that box being able to
Yep.
get KMS. And the KMS gives me back my decryption key, which I can then use to decrypt the data in the database.
Yes.
So from that standpoint, that seems to fall in most of these.
Absolutely. So what you described is it's not, you're not even handling the secret, not really. Well, so are you using the decrypt API?
So I'm not sending the social security number to them and they're sending it back. I'm basically saying, give me my key, and then I'm actually doing
Okay.
AES decryption in memory. So I do actually see.
Yeah.
So if an attacker was on that box, they could get the actual decryption key.
Yeah, but you will. So that model. So I'm trying to. Let me back up and try to make this a little more relevant. Like say we had another service on here.
So for his, your problem, the attacker would have VM.
Correct.
Not some more problems.
Well, it needs to be in the compute container. Yeah, yeah. It needs to be able to access this metadata endpoint and get a credential. It's really kind of where it goes to. But anyway.
And the data store itself, the encryption key by itself is useless, right? Without the company data to encrypt something, so you need the database as well, which I guess.
Right, which presumably
they can get to as well.
they might be able to. Yeah, yeah. But I think that's actually a very nice approach. So what's happened? What was just described is like the application. DB. So what the application does is it gets some credentials, and as it's processing traffic, before it stores that data in the database, which is sensitive PII, or it used to be anyway. I don't know if it is anymore. Like, should we? Because so many people did not take the care that you did. But before putting that data in the database, you grab a key out of KMS and encrypt it, encrypt the data and put it in the database. And the nice thing about KMS is that there are policies that say like what compute instances can access a particular key and retrieve a key to perform that encrypt or decrypt operation. So the execution role was being leveraged here, which is very important. And so one of the patterns that I was hoping you were going to describe, actually, that I really like and want to work with some clients to implement, but we need to find someone to do it, is like instead of pulling the key, the encryption key, actually into memory inside the application, you can stream your data through the encrypt and decrypt APIs on KMS, and you never see the key, so you can't leak it. And another thing is because these are APIs, you can separate the ability to read and write, to encrypt and decrypt. So you could have a process that is ingesting, and it only has access to encrypt data, and something downstream has access to only decrypt data. And so you can establish nice properties like literally the only thing that can change data is like this one ingest process. Because it's the only thing that has access to the key to encrypt it and blah, 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 blah. So I think that's like advanced.
Yeah, we also
or more
do some
advanced.
monitoring on KMS too. Like I can say, normally I do 10,000 decrypts a day, and all of a sudden, fuck, there's
Right.
really decrypts that are happening when someone's probably
Right.
trying to decrypt the database. So
Right.
they do charge you per decryption, I believe. So it's like
Yep.
1 million penny per decryption.
Yeah.
So,
Yeah, it's resource usage-based pricing, consumption-based billing. Yeah. So there's a whole bunch of stuff that I didn't show over here that you can, once you establish a model where you're copying and making copies, well, it's actually not even dependent on that. Like you should be auditing like your usage of your secrets. And then with that data, you can do things like determine whether or not there's a higher than usual number of like reads of a certain secret, or if application B is reading application A's secrets. Now, of course, you should prevent that via policy, but also audit it. And then also do things like check and see if any credentials, let's say administrative credentials, are being used or roles are being used to read those secrets that are unexpected, like from a principal that's outside of your account. And yes, you can use IAM policy and all the various policy languages to like narrow this down. But like, what if you didn't? And it's kind of a belt and suspenders approach. And like, let's have audit governance. This is a whole audit governance compliance side of things. And if you're interested in that stuff, I'd love to talk with you. Which actually brings me to another thing, another ask, actually. So I did mention at the beginning of this, I've written about this stuff on a blog called No Drama DevOps. Love it if you would read that stuff and ask me questions. I also really love it if you complete a 5-minute-ish survey. Survey Monkey says it's 5 minutes. It might be 10. I'm gonna share all this stuff and put some links on the meetup event as comments. But this survey, I'm trying to understand how people are delivering secrets and what problems they're facing, because I have this like dream of kind of leveling up, particularly the automated delivery and the safety of the automated delivery of secrets, and then filling in a lot of that stuff around audit and governance and compliance that I think a lot of people aren't that interested in doing, or like they never get time to do it until they're Equifax at a congressional committee, explaining why no one noticed that there were like these processes reading this like shared secret file. Anyway, thank you so much for attending today. I hope you found it useful. I'm gonna stop recording, but stick around and make sure you get snacks.